ECE 23 Performance Task Number 5 by Raymond Lorca as ECE 3A. Continuous phase frequency shift keying, or CPFSK, is a modulation that may be described as a typical frequency shift keyed FSK signal with symbol time limits limited to preserve continuous phase. This restriction has significant benefits in terms of error rate performance signal and signal spectrum confinement. The modulation is described in this work along with a connection to the more generic continuous phase modulation, or CPM. The CPFSK spectrum is presented as well as optimal coherent and non-coherent receiver structure. Finally, the performance of CPFSK in terms of coherent and non-coherent error rate is discussed. Continuous phase frequency shift keying, or CPFSK, is a promising modulation format because it has a compact spectrum and its receiver sensitivity can be improved with differential detection. A CPFSK modulator is implemented by embedding two MZMs in each arm of a main modulator 21. In the CPFSK modulator, synchronization between the clock and data signals is required, similar to the case of pulse carver and data modulation in RZ-DPSK transmitter. Theory of CPFSK. So this is the formula of CPFSK. Corresponding CPFSK signal in where AC is the amplitude of the CPFSK signal, FC is the base carrier frequency, and DF is a parameter that regulates the frequency deviation of the modulated signal. The CPFSK signal's continuous phase is determined by the integral contained within the cosines argument. An integral over any finitely value function with which MT is presumed to be will not contain any discontinuities. If the message signal is supposed to be casual, the integral's lower and upper bound shift to 0 and t respectively. This isn't to say that MT has to be continuous. In fact, most perfect digital data waveform have discontinuities. Even a discontinuous message signal, on the other hand, will generate a correct CPFSK signal. This isn't to say that MT has to be continuous. In fact, most perfect digital data waveform have discontinuities. Even a discontinuous message signal, on the other hand, will generate a correct CPFSK signal. So this is the phase release of the triple H CPFSK sham with H 1/2, 1/4, 0, 1/2, and 1. Phase release of the triple H CPFSK sham with H 1/4, 0, 1/2, 1 is shown in the figure 1b. Its implementation is as follows. The odd bit of the input binary data is used to decide H 1/4 1 is equal to is corresponding to the data 1 H 1/4 1 is corresponding to data 0. The even bit of the input binary data is utilized to decide the phase slope during a symbol interval. If the even bit is 0, the corresponding slope during this symbol interval will be h pi equals to t. Else, if the even bit is 1, the corresponding slope during this symbol interval will be h pi equals to t. However, if h1 port 1, the phase slope will be according to this mapping rule, this will cause a faintness. The phase difference between the different input binary data at the next sampling will be 2, and thus it is difficult to demodulate the next symbol. Therefore, to eliminate this phase faintness, H140 is introduced to the proposed scheme if H141 and the even bit in 0 slope T will be adopted. Else, if H141 and the even bit is 1, slope 0 will be selected. Then the encoded triple H CPFSK signal is sampled every T, and this sampled data sequence is fed into an inverse fast Fourier transform IFFT module to generate the triple H OFDM CPFSK signal. Receiver, the triple H OFDM CPFSK signal is demodulated by a FFT module. Then together receive binary data. A simple different decoder is demonstrated. As the phase state, the present symbol is determined by the cumulative phase of the previous symbol and input binary data to data at present time. We subtract the phase state of the last symbol from that of the current symbol. The subtract is only determined by the current input binary data. Then we can get the current input binary data from the subtract directly. A decision block of differential decoder is shown in figure 2. After angle FG block phase is limited to negative pi and pi. Therefore, the differential discussion block is limited to negative 2 pi and 2 pi. Okay, summary. CPFSK is a popular version of FSK, which is a special case of analog frequency modulation. So this is the formula of theory of CPFSK, and CPFSK is under MSK, which means minimum shift keying. That's all. Thank you.